Welcome back. We're going to do 6.3 in today's lesson, which is how to factor trinomials of this form, ax squared plus bx plus c. Okay, now there are actually many methods for factoring such trinomials. I'm just going to focus on one main method, which is really is a guess and check method, because you can spend hours learning other methods, and you may have learned them maybe at some time in high school or something. And if you know other methods, you're certainly welcome to use them. I just don't teach them all because it's really not necessary. And a lot of those little tricks people tend to forget over time anyways. But you won't forget the guess and check method because it's pretty easy to remember. You guess and you check. Alright, so we're just going to learn by example. So we're going to work lots of examples today. Okay, so we're going to start by factoring this trinomial. Now, just like factoring in the previous section, trinomials will still, if they factor, they'll still factor into a product of two binomials. Maybe leave a little extra space here because there's more numbers that's going to go inside. So the same process still applies in that the first two terms have to multiply to 4x squared, and your last two terms have to multiply to positive 5, and then the outside term and the inside term have to add to positive 12x. So we'll get to that part last. Okay, so first, let's handle the 5 because there's only one way to break down 5 into a product, and that's as 5 and 1. So no matter what we do, one of these is going to have a 5, positive 5 for the last term, and the other will have a positive 1. And I know the signs are both positive because all the signs over here are positive. Okay, so the question then is, what goes here and here? Alright, so whatever goes there, this is where I start guessing and checking. It has to multiply to 4x squared. So there's a couple ways to do it, but no matter what we do, you're going to have an x and an x. Now there's probably going to be a coefficient here and here. So that's where we have to guess a little bit. Okay, so let's write out all the ways to break down 4. And let's do this just over here to the side. 4 breaks down into 2 and 2 or 4 and 1. So it's going to be one of these two ways of breaking it down. And now order does matter because if I put a 4 here and a 1 here, that's different than if I put a 1 here and a 4 here, because the 4 here is with the 1, whereas if I put the 4 here, it's with the plus 5. So order matters. So there's really only one way to put 2 and 2, but two ways to put 4 and 1. So let's try the 2 and the 2 here. Okay, so remember, use pencil and eraser because this is guess and check, so you might get it wrong. Okay, so let's try a 2 there and a 2 here. And then we check by foiling. So let's check here. The first two terms are 2x and 2x. Multiplying those gives me 4x squared. The outside terms, so there's just first. The outside terms are 2x and positive 1. So plus 2x. The two inside terms are 5 and 2x. That's positive 10x. And the last two terms are 5 and 1, which are positive 5. And did we get it? Let's see. We have 4x squared, a plus 5 at the end, a plus 5 at the end. And 2x plus 10x is 12x. So that does work. Okay, sometimes you'll get it right on your first guess, other times you won't. But that works there. So that is the factored version of 4x squared plus 12x plus 5. Okay, let's do another example. And what I recommend you do on all of these examples is pause the video at this point, try it on your own, and then restart the video and see if you got it right, or if you get stuck, then watch with me and work it with me. So we'll go ahead and set up our parentheses. Okay, now let's see. The first two terms have to multiply to 2x squared. There's only one way to break that up. One of the terms will have to be a 2x and the other term will have to be an x. So we can go ahead and write that in for sure. Now the last two terms are going to need to multiply to a 15. And so there's a couple ways to do that because 15 breaks down into 5 and 3 or 15 and 1. So let's start with the 5 and 3 option. Now the question is, which one do you put where? And remember, order matters because these are not the same. One has a 2x and the other has an x. And again, everything's positive, so we'll have all positives. Okay, so the part I'm guessing on is here and here. Let's try putting a 5 here and a 3 here. And let's see what we get. Foiling that out, we'd have a 2x times x is 2x squared. Good. The outside terms are 2x times 3, which is 6x. The inside terms are 5 times x, which is positive 5x. And it looks like it's going to work because 6x plus 5x is 11x. And the last two terms multiply to 15. So that one did work on my first guess there. Oops. Clicked on the wrong page. Alright, now let's try another one. So again, make sure you're pausing and trying them on your own first. Okay, now this one has a minus, but the process is the same. The last two terms have to multiply to be a 1, and of course there's only one way to do that, is to put 1 and 1. Now, they have to multiply at a positive 1, yet the inside terms have to add to a negative number. The only way you can add to a negative number and multiply to a positive number is if they're both negative. So we know that's there for sure. Okay, now the first two terms have to multiply to 6x squared, so they're both going to have an x. The question is just, what is the coefficient of that x? So, let's see, 6 breaks down into 2 and 3, or 6 and 1. So let's try 2 and 3. So I'm going to put a 2 here and a 3 here, and let's FOIL that. 2x times 3x is 6x squared. The outside terms, 2x times negative 1 is negative 2x. The inside terms are negative 1 times 3x is negative 3x. And the last terms are negative 1 times negative 1, which is positive 1. And again, I'm getting lucky, but on my first guess, I got negative 5x as the middle term. So that, again, does work. Okay, let's do another one. So we set up the parentheses. Oh, now this one is probably going to be more challenging because, oops, erase that there, because there are multiple ways to multiply to 12. And well, there's only one way to multiply to 2. So maybe it won't be as challenging as I had initially thought. So let's see. To get a 2x squared for the first term, one is definitely going to have to be 2x and the other is going to have to be an x. Now again, we have a negative for the middle term and a positive number for the last term, so they'll both have to be negative. And the question is, what goes here and here? Those last terms have to multiply to 12. 12 breaks down into 12 and 1, or 3 and 4, or 6 and 2. So we have lots of ways to do that. And as far as which one's going to work, I don't know. So it'll be one of these combinations. And remember, order matters, so there's really 6 possibilities here. And if none of those 6 work, then it means it doesn't factor. But we do have to try all 6. And usually you'll get it right before your last try. Usually the ones, I shouldn't say usually, but pretty often you'll find that the numbers that are smaller work more often. So I'm going to start with the 3 and the 4. So let's try putting a 3 here and a 4 there and see what happens. So foiling this, I get 2x times x is 2x squared. The outside terms are 2x times negative 4 is negative 8x. The inside terms are negative 3 times x is negative 3x. And the last terms, negative 3 times negative 4 is positive 12. And these two middle terms do add to negative 11. So I'm getting lucky today and getting them all right on my first guess, but that does work. Make some more space in here. Okay. So let's try yet another one. Now this one, the signs are different. The last term is negative and the middle term is positive. Okay, and this one I think will be more challenging because There's 2 ways to break down 4 and 2 ways to break down 35, and we have a negative sign going on. So there's lots of options here. Now the middle term is only 4x, so my guess is that we're not going to break 35 down into 35 and 1 because that would give us a really big middle term. So let's go with, on breaking down 35, let's go with 5 and 7 before we try, 5 and 7, before we try 35 and 1. Most likely 5 and 7 will probably somehow get us a 4 in the middle term. So let's try 5x and 7x for the first terms. Now here's where the combinations begin, because this negative 4, there are lots of ways to get negative 4. We could do negative 1 and positive 4, or we could do negative 4 and positive 1, or we could do negative 2 and 2, and order here matters on all three possibilities. So as you can see, there's lots of combinations, but it usually, once you do it one, you'll kind of get an idea of how far off you are and what you should try next. So at first you just have to give it a try. So let's just try 2 and 2. I think the negative 2 and 2. Let's try this one first. Okay. So let's put a 2 here and a negative 2 here and see what happens. So first terms do give me 35x squared. The outside terms are 5x times negative 2 gives me negative 10x. The inside terms give me 2 times 7x, which is 14x. And the last two terms give me 2 times negative 2 is negative 4. And look, I'm getting lucky again because negative 10x plus 14x is 4x. So I told you you usually don't have to try all combinations. What you'll find is often these smaller numbers work. So that's why I went with those first. Okay, so there's that one. Let's do yet another. Gonna make sure you get plenty of practice at this. Okay, so on this one, the first two terms have to multiply to 4x squared, so they're both going to have an x, but I don't yet know what those coefficients will be because it could either be 4 and 1 or 2 and 2. The last terms need to multiply to negative 3. Well, at least there's only 2 ways to break that up. It could be negative 1 and positive 3 or negative 3 and positive 1. So first let's try the negative 1 and positive 3. I don't know if that'll work, but we'll just give that one a try first. And then let's try breaking the 4 down into 2 and 2, and if that doesn't work, then we'll try the 4 and 1. So let's go with 2 and 2 first. Okay, foiling that out, we get 2x times 2x is 4x squared. Outside terms give me 2x times positive 3 is positive 6x. Inside terms give me negative 1 times 2x is negative 2x. And the last terms are negative 1 times positive 3, which is negative 3. Now, as you can see, this one didn't work because 6x minus 2x is 4x, which is not 11x. So that didn't work. Now, I recommend changing only one thing at a time. Okay, so I'm going to erase a little bit here. The only thing I'm going to change on this round are these coefficients right here, the 2 and the 2. So let's try putting a 4 and a 1. So we'll try all the combinations of changing these first two coefficients, and then if that doesn't work, then we'll start trying to change the second coefficients with different combinations of the first. So using the 4 and the 1, let's see what happens. And remember, order matters, so if this doesn't work, I'll try 1 and then 4. But okay, first terms give me 4x squared. Middle term, outside terms give me 4x times 3 is positive 12x. Inside terms give me negative 1 times 1x, which is negative x. And last terms are negative 3. Looks like that works. 12x minus x is positive 11x. So got that one on the second try there, which isn't bad either. Don't get discouraged if it takes you 3 or 4 tries. I may just be getting lucky because I've done some of these before, but you know, again, pick the smaller numbers first and try all combinations. You'll eventually get there. All right, let's try another one. This one is a little bit different, you'll notice. This says 21x squared for the first term. So 21 breaks down into 3 and 7, or into 21 and 1. It's probably going to be the 3 and the 7. So let's try 3x and 7x and see what happens there. Then the last terms have to multiply to negative 2y squared. So both of those have a y. And one of them is going to have to be positive 1y, the other one's going to have to be negative 2y, or we could do negative y and positive 2y. So I'm going to try this first one here, positive y and negative 2y, and we'll just see what we get with that. So foiling, we get 21x squared, outside terms 3x times negative 2y is negative 6xy, inside terms y times 7x is positive 7xy, and then the last terms are y times minus 2y is minus 2y squared. And I can see that that did not work because 7xy minus 6xy is 1xy, not 11xy. So first I'm going to just try changing the stuff in pink. Instead of positive y and negative 2y, I'm going to try switching the negative signs and see if that works. So I'm going to try putting, let's see, I had the negative 2 there, so I'm going to try putting the negative 2 over here and the positive over there. Now if that doesn't work, we can switch the signs as well. So let's see. Let's try this one. So we have 3x. In fact, I'm just going to start multiplying only the outside and the inside terms because you probably noticed we get the first term right and the last term right every time. So I'm just going to do outside terms and inside terms and see if we get 11xy. So outside terms here give me 3x plus y, which is 3xy, and the inside terms are negative 2y times 7x, so negative 14xy, which is negative 11xy. Now that's close, but we want positive 11y. So if that happens, what I recommend doing is trying to change these signs. So let's switch just the positive and the negative signs and see if that works. So let's put a positive 2 here and a negative y there. So then the outside terms would be 3x times negative y, or negative 3xy, and the inside terms would be 2y times 7x, or positive 14xy, which is 11xy. So that did work. This next one is pretty similar to the one I just did. It just has different letters. The first terms need to multiply to 14a squared. 14 breaks down into either 2 and 7, or it's a 7, or 1 and 14. So let's go with 2a and 7a to begin with. It's more likely to work. Then the negative 2b squared could break down into a couple of ways. It could be negative b and positive 2b, or the order there could be reversed, or it could be negative 2b and positive 1b. So we'll just try the first combination I have written here first. So let's try negative b and positive 2b. Now I know one has to be negative and one has to be positive because they have to multiply to a negative number, but we want them to add to negative 3ab. So the outside terms here give me 2a times 2b, or 4ab. The inside terms give me negative b plus 7a, which is negative 7ab, which does add to negative 3ab. Okay, and of course you can check the first term is 14a squared, and the last term, negative b times positive 2b, is negative 2b squared. So that one does work. Alright, trying the next one here. We have 5x to the 4th plus 34x squared minus 7. So this is similar to one we did on the last section, in that we had an x to the 4th term and an x squared term. So I'm going to start with what looks like the easy part, and that's the fact that the last terms have to multiply to negative 7. So one of them has to be 7, the other has to be 1. Now I don't know where the plus and minus signs go. They could go either way. So I'm going to start by putting a plus sign with the 7 and a minus sign with the 1, but that may change later. Now the first two terms have to multiply to 5x to the fourth. So one of them has got to be 5x squared and the other one has to be x squared. That's the only way to get 5x to the fourth and still get a middle term with x squared, is to break it up into x squared and x squared. So multiplying the outside terms together, we have 5x squared times negative 1 is negative 5x squared, and the inside terms give me positive 7x squared, okay, and which is 2x squared, which is nowhere near the size of 34x squared. Now to get a 34, notice that's pretty close to 35, which is 5 times 7. So maybe I should write it so that somehow I'll be multiplying the 5 and the 7 together. So what if we switched and put a 1 here and a 7 here? Forgive me for not erasing, but it would be more difficult to erase here. So let's try that. Okay, now let's try multiplying these outside terms. This would give me 5x squared times negative 7, which is negative 35x squared. And the inside terms are positive x squared. And that's closer, that's negative 34x squared. And if you get the opposite sign, remember the trick is to switch the signs. So let's make the first one negative and the second one positive. And try that. Then the first terms give me 5x squared times x squared, which is 5x to the fourth. The outside terms are 5x squared times positive 7, or positive 35x squared. The inside terms are negative 1 times x squared. And the last terms are negative 7. And this does add to negative 34x squared. So this does work. Alright, here's another one very similar, so make sure you pause the video and give this one a try on your own first. Now the last two terms are going to multiply to the same thing, negative 7. So I'm just going to try 1 and 7. I'll put the negative with the 1 and the positive with the 7 for now, but we may change that later. The first two terms have to multiply to 2x to the 4th, so one of them has to be a 2x squared and the other one's got to be an x squared. So let's see if this order of things works. The outside terms here would give me 2x squared times positive 7, or 14x squared. Inside terms give me minus x squared, which is 13x squared, which is too big. That's not the same as negative 5. Now I have a 7 and a 2 involved, which could add to negative 5. So maybe I want to put them so that they're not being multiplied. So we're here, they're on outside terms, so they're being multiplied. So let's maybe switch the 7 and the 1. I'm going to make that one into a 7. Let's make this one into a 1 here and try that. Then we have 2x squared times x squared is 5x to the 4th. The outside terms are 2x squared times 1, or positive 2x squared. The inside terms are negative 7x squared. And the last two terms are negative 7. And that does work because 2x squared minus 7x squared is negative 5x squared. Okay, let's try this next one here. Factoring 6xy squared plus 33xy minus 18x. Now the first thing you might notice is all the terms have an x. And if you try to factor it straight like it is into a product of two binomials, there's no way to get an x in every single term. But the nice thing is all three terms have an x, so we can factor it out before we even begin to factor the trinomial. Also, we could also factor out at least a 3 because all three of these terms have a 3 in common. So let's factor out a 3x to begin with, and then we'd be left with 2y squared from the first term, positive 11y for the second term, and minus 6 for the last term. Alright, now let's see if we can factor this trinomial a little bit further. So I'm going to carry along that 3x there. And let's try breaking this down into a product of two binomials. 2y squared has to break down into 2y and y. Now the 6 could break down into a couple things. Could break down into 6 and 1 or 2 and 3. And one of them will have to be positive and one will have to be negative so that they multiply to a negative number. So because this middle number here, 11, is a lot bigger than the other numbers involved, 2 and 6, I'm actually going to start by trying the 6 and the 1 out, because that can get you bigger numbers by using the combination that has bigger numbers in it. So let's try putting the 6 here and the 1 here to begin with. And let's try making, well, let's see, actually let's make an educated guess as to where to put the plus and where to put the minus. Now we want them to add to a positive number, so I'm going to try putting the plus by the 6 and the minus by the 1 in hopes that that will get me a positive number. So I'm not multiplying out the 3x at this point, I'm only focused on this part. Now when I FOIL this out, we'll get 2y squared, which is what we want up here. The outside terms are 2y times negative 1, or negative 2y. The inside terms are positive 6y. And the last two terms are negative 6, which is what we want. But negative 2y plus 6y is positive 4y, not positive 11y. So I need to get bigger. Now, if you notice, I have a 6 and a 1 in the problem and a 2. Now, if I multiplied this 2 times the 6, I would get 12, which is really close to 11. So I'm going to switch the 6 and the 1 here. So let's try putting the 6 over here on the right. That way, when I do the outside terms, I'll get 12y. Now I want to make sure I get a positive in the middle term, so I'm going to put the plus sign with the bigger of the two numbers, the 6, and the minus with the 1. Now when we FOIL this out, we get 2y squared for the first term. That works. The outside terms give me 2y times positive 6, which is 12y, and the inside terms give me negative y. And that is good because that adds to 11y. And then the last terms do give me negative 6. So this looks like a fully factored version of that trinomial. All right, and let's finish this up with one last example. Okay, we want to factor. Now this is different because there is a negative in front of the whole thing. And we haven't done any problems where there's a negative in front of that first term there. So what you can do, and what I recommend doing so that it follows the same patterns you're used to, is just factor out a negative 1 from the very get-go. So I'm going to start by factoring out a negative from everything, which will leave me with 5x squared plus 19x minus 4. Now this looks like it'll be easier to factor without having a negative in front of the 5. So now let's try to factor it into a product of two binomials. 5 only breaks down into 5 and 1, so one of these must be 5x and the other must be x. 4 breaks down into either 2 and 2 or 1 and 4. Now one of them, of course, has to be positive and the other has to be negative. And I want to get a really big middle number. So to get the big middle number, I'm going to start by guessing with the 1 and the 4. And let's see, this middle number here is a 19, which is close to 20. So if I put the 4 here and the 1 here, then when I multiply my outside terms together, I'll get a 20x. So let's try that. And I want to have a positive 20x. So let's put the plus with the 4 and the minus with the 1. Now I'm not including this negative out here. I'm just going to multiply out these two binomials. So first terms are 5x times x, which is 5x squared. That works. The outside terms are 5x times 4, which is positive 20x. The inside terms are negative x. That is positive 19x, so this should work because the last term is negative 1 times 4, which is negative 4. So as you can see, the more you do of this, the more experienced you get, the better guesses you'll make based on seeing how the numbers are going to multiply together. So that's it for factoring trinomials of this form. What I want to look at next is how to factor perfect square trinomials, which really there's no difference when you're working them, but there's a different way to write the answer. Okay, so this is called right here, x plus 4 quantity squared. This is called a perfect square trinomial because it's a binomial times itself. Okay, what x plus 4 all squared means is x plus 4 times x plus 4. right? Anything squared is itself times itself. Okay, this is not the same as x squared plus 4 squared. Because when you multiply x plus 4 times x plus 4, you have to FOIL. So you're going to get another inside term there. So do not try to distribute that square out and say, oh, that's just x squared plus 4 squared. That is not correct. What is correct is to FOIL here. So we'd get x times x is x squared. The outside terms give you x times positive 4x. The inside terms give you the same thing, positive 4x. And the last terms are positive 16. So we get x squared plus 8x plus 16. All right, so let's expand these out as well because we're going to use them here in a minute. So, but the idea here is that sometimes if your factor is the same, x plus 4 and x plus 4 it's the same, you can write that as x plus 4 quantity squared. Okay, that's the new thing here. All right, now let's expand these two because we're going to use them in just a moment. A plus b all squared times a plus b all squared. That's a plus b times a plus b. FOILing, we get a squared plus ab for the outside terms plus ab for the inside terms. So adding those, we'll have plus 2ab. And the last terms are b squared. Okay, multiplying these two, I have a minus b times a minus b gives you a squared for the first terms, negative ab for the outside terms, negative ab for the inside terms. Adding those would be negative 2ab, and the last term is negative b times negative b, or positive b squared. Okay, so now let's use this to factor these down here. This means that a squared plus 2ab plus b squared, that's what we have up here, factors into this, what we started with, a plus b quantity squared. Or if you have this, a squared minus 2ab plus b squared, that's what we have here, that's going to factor into a minus b all squared. So the idea is if the middle number is twice what these outside ones are, okay, twice of what the square root of the outside ones are, then you'll have a perfect square. You don't have to recognize that in order to factor these. Okay, now this one, let's just factor it the regular way like we've been doing, and you'll see what we get. So x squared plus 20x plus 100. Everything's going to be positive. X squared breaks into x and x. Let's try just putting 10 and 10 for 100. And if you FOIL that out, you'll get x squared plus 10x for the outside terms plus 10x for the inside terms plus 100 for the last terms. And the plus 10x does add to plus 20x. So if you notice, okay, you take the square root of 100 and you get 10. And then you double that, you get 20. So if you have something of that pattern, that is when this is actually a perfect square trinomial. So what you should recognize here is that you wrote x plus 10 twice. X plus 10 times x plus 10. So you can write this as x plus 10 quantity squared. Let's do another one. So let's try factoring 9r squared plus 24rs plus 16s squared. Now with something like this, you have lots of numbers. I would always look for, is there anything that you can factor out of all the terms, a greatest common factor that you can pull out first that will then make it easier to factor. And if you look, let's see, 3 is a factor of 9, 3 is a factor of 24, but 3 is not a factor of 16, and 16 has factors of 4, which aren't factors of 9. So unfortunately, there are no common factors that we can pull out of all three terms. So let's just go straight into factoring it into a product of two binomials. 9 breaks down into 9 and 1 or 3 and 3. Okay, let's go with 3 and 3 first. 16 breaks down into 4 and 4, 16 and 1. Well, let's go with 4s and 4s first. Everything in this problem is positive, so we'll have plus signs for both. So if you'll notice, I wrote the same thing twice, 3r plus 4s times 3r plus 4s. Okay, so if this is correct, then this is a perfect square trinomial. So foiling, we get 3r times 3r, or 9r squared. The last two terms give me 4s times 4s, or positive 16x squared. Those work. The outside terms are 3r times 4s, which is positive 12rs. And the inside terms are the same, positive 12rs, which do add to 24rs. Okay, so that does work. So we can write this as 3r plus 4s quantity squared. Now, how do you recognize these? Well, if you take the square root of 9, you get 3. You take the square root of 16, you get 4. Multiply those, you get 12. You double it, you get 24. I know that's kind of hard to recognize, and often when I run into these, when I'm really solving math problems, I don't even recognize them when I see them. I just factor them the old-fashioned way here and then recognize, oh, I got a perfect square trinomial, so I write it like this. So you don't have to recognize these in order to factor them. Now let's do another one. 25x to the fourth minus 20x squared plus 4. Okay, now the square root of 25 is 5. Square root of 4 is 2. Double that, you get, multiply them, you get 10. Double that, you get 20. The only catch here is there's a negative sign, so let's see if we can handle that. If they're going to multiply to positive 4 and add to a negative number, they should both be minus 2's. They should both be negatives. And we have a 5x squared and a 5x squared here is how I'm going to break down the 25x to the fourth. Let's see if that works. The outside terms are 5x squared times negative 2, or negative 10x squared. The inside term is the same thing. That does add to negative 20x squared, so that works. So you get 5x squared minus 2 quantity squared for the factored version of that. And one more to finish up this section. Now on this one, you might notice the powers of n are a little different than what we've been working with, but we can factor out an n from everything. And let's see, are there any other constants that we can factor out of all three of these terms? Well, a 4 and a 2 are factors of 8, and it looks like a 4 is a factor of all three terms. Take that back. 4 is not a factor of 50, but 2 is a factor of all three terms. So we could take out a 2n, and we'd be left with 4n squared minus 20n to the first plus 25. So the 2n will carry along. Let's see if we can factor this. 4n squared, let's try breaking that up into 2n and 2n. And let's try breaking the 25 up into negative 5 and negative 5 using negatives because I want my inside terms to add to negative 20n. And let's see if that works. If I FOIL out just this part here, I get 2n times 2n, which is 4n squared. The outside terms give me 2n times negative 5, or negative 10n, as do the inside terms. And the last terms do go to negative 25. My inside terms, negative 10 minus 10n, do add to negative 20n. So this would be a factored version. I can write it more simply. I can write it 2n times 2n minus 5 quantity squared. So that's it for section 6.3. We're actually going to skip section 6.4 because it's just more ways to factor everything I did here. So if you're interested, you're certainly welcome to look into the book on that. Or if you already know how to factor using grouping to factor trinomials, you're welcome to do it. It's just an extra method